This is an addition to your study guide, and it's going to be explaining the angle-launched projectiles that don't land on the same level that they're projected from. So it's like J's. Their trajectory is like part of a parabola that could either be like this, like seen here, or it could be like this. It ends lower or higher than where it was projected. Okay, so this is like this one right here. So let's do an example. So we're going to set up an XY table. XY table for what we have given here from start to the highest point. So this is going to be my VF right here. So this is weird because I don't have VO. So I don't have VOX or VOY either. Not to worry. And I don't have the angle either, the launch angle. But what do I know? AX is equal to 0. Always. AY is negative 10 meters per second squared. So what do I have? I got, look right here. Delta Y is 17, positive 17 meters because it starts at this level, ends up here to the highest point. Okay, delta X, as you can see up here, is given 26 meters. Okay, so what else do we know? Okay, let's look at VO. VOX. We don't know what that is. Okay, how about VOY? We don't know what that is either. Okay, let's look at the top now. VF. Okay, how about VFX? Okay, VFX, I don't know what that is, but I do know that it's equal to VOX, whatever that is. But I still don't know what it is. How about VFY? Yes, I definitely know that's what at the top, the Y, this piece shrinks down. The VOY shrinks down to 0 at the top, so I know that. Okay, so I've filled this table as much as I can. Okay, let's now find the Y component of VO. So VOY. Okay, so we're looking for that. Okay, so to do that, I'm going to need to use the Y part of this table. So give me an equation with VOY, VFY, delta X or delta Y, and AY. No. Look at your equation sheet. What would that be? So I looked, and it's going to be VF squared equals VO squared plus 2 acceleration delta X. But since we're doing Y values, let's put delta Y instead. Okay, so let's plug in our values. 0 squared equals VO, that's what I'm looking for, VOY squared plus 2 times negative 10 times delta y is 17. So working this out, I get 2 times 17 is 34, times 10 is 340. So VOY squared minus 340 equals 0. So VOY squared is equal to 340. So VOY is equal to the square root of 340, which equals 18.4. 18.4 meters per second. Okay. Next question, next part of this question I ask is find the time it takes to get to the highest point. So I'm looking for t to get to the top. So, I can use the VF that I just found to do that. So let's look what I got. Look back at this thing right here. I have VOY now. I have VOY. So I could use what equation? I can do A equals VF minus VO over T. I'm going to use the Y values. Okay, I'm looking for VOY. Actually, I'm looking for T. I got VOY now, right? Right here. I have it. I just solved it. So, cross multiply. Well, plug in first. Negative 10 equals VFY, which is 0, minus VOY, which is positive 18.4 over T. And therefore, cross multiply, negative 10T equals negative 18.4. So T equals negative 18.4 divided by negative 10, which just simply equals 1.84 seconds. I'll just say 1.8 seconds. So that's the time it takes to go to the top, the highest point. So find the x component of VO. Well, now that I got time, I can do anything. So I'm going to go to the x side. Look at the x side over here. And we're trying to find VOX. So I got A, I got VOX I'm looking for, I got delta X, and I got VFX, which is the same thing, but I also have time because I just found it. So look for an equation with all those things. How about this one? Delta X equals VOXT plus AX times VOT plus AT squared over 2. Okay? Now, AX is 0. So it crosses this whole term out. So basically, it's simple. 26 is equal to VOX times the time, which we just found to be 1.8 seconds. So VOX is equal to 26 divided by 1.8, which 26 divided by 1.8 comes out to be 14.444. So 14.4 meters per second. So that is the VOX right there in that picture. Find VO. Well, look, you have, at this point, you have VOY, and you have VOX, and VO is what you're looking for. So basically, if you look at my equation sheet, Q equals, to find this piece, that's just like a right angle triangle. You move this piece over where the dot line is here, and you make a right angle triangle. So this is VOX at the base, which we just found to be 14.4. And VOY we found over here to be 18.4. So what's VO? I'll use Pythagorean theorem. So it's 14.4 squared plus 18.4 squared, square root of that. So 14.4 squared plus 18.4 squared. Then take the square root of that answer. I get 23.4 meters per second. 23.4 meters per second. Okay, to find the launch angle, you would just use my equation sheet. It's inverse tangent of VOY over VOX. I'm just using my equation sheet. Angle is inverse tangent of QY over QX. Okay, so what would that be? Inverse tangent of VOY. Where is that? Over here. 18.4 divided by VOX. Where is that? Where is that? Right here in letter D, 14.4. So that works out to be 51.95 or 52 degrees from the horizon. Okay, let's find the y component of the impact speed on the slope. So it's right here. So the y component would be like pointing down, VFY. But I know VFX. I know VFX is going to be equal to VOX or VFX before. So I know I got two VFXs now. So I'm talking about the second VF. Okay, so I don't want to confuse this too much. So the VFX stays the same as it was at the beginning, which is VOX, which is up here. What do we solve it for? 14.4. So let's draw. Let's just put that. So to find the final speed y component, that would be this part right here. Let's see what I got. I got VOY at the very beginning is what? We found that in part, this part, part B. 18.4. I got AY is negative 9.8, or negative 10. Okay? I have the total time. No, I don't have the total time to get to the highest point, so I can't use the time. But don't I have delta Y? From the start to the finish. That would be the 9.5 that you see right there. The 9.5 that you would see right there, which I kind of wrote over, which I shouldn't have. So, but it's positive because from here to there is 9.5. So delta Y is positive 9.5. So now I can do what equation? VF squared VO squared is 2AX. VF squared equals VO squared plus 2A times delta Y. Okay? So these are all the Y ones. So VFY squared equals VOY, which is 18.4, as shown right there, plus 2 times negative 10 times delta Y, which is, like I said, 9.5 in the picture right there. So I can just work that out. Okay, this comes out to be 148.56, so I'll say that 149. So VFY squared is 149, so VFY, take the square root of 149, and you get 12.2. Okay, so I just found VFY. Okay, so where's letter H up here? Find the time it takes from launch to impacting the where it hits the hill right there. So, so we're gonna find the total time. So, I don't know. You can do all kinds of stuff. I found VFY, right? I know VOY, so I'm looking for T again. Time 2, not to be confused with the time it takes to get to the highest point. So VOY is already found way over here as 18.4. VFY was found as way over here. Did I find it? Yeah, right here. 12.2. We know AY equals negative 10, so I can just use a simple equation. A equals VF minus VO over T. So negative 10 equals, let's put Y's and everything. Negative 10 equals 12.2, which is positive. Well, that's really negative. Whoa. So VF is negative 12.2 because it's going down. The speed is going downward. So the speed, negative 12.2 minus the original speed, VOY, is 18.4. Divided by T. So T comes out to be 12.2 plus 18.4, 30.6, negative 30.6 over negative 10 comes out to be negative 3.1 seconds. Negative 3.1 seconds. Let's write that better. It's not negative. Negative or negative is positive. You can't have a negative. So it's 3.1 seconds is my answer for the total trip time. Just check. It's faster than the 1.8. I mean, it's a longer time than the 1.8 seconds to get to the top. Okay, and then finally in this problem, find the impact speed on the slope. Well, okay, so that would be right here. Let's look at the picture. That'd be right here. That's VF right there, that black arrow. So if we did this, this is VFY. This is VOY. Actually, VFX. Give me my. Which is the same as VOX. So, VFY. No, VFY is at the where it hits, not the VFY at the top. Sorry. So it's negative 12.2. It doesn't matter at this point. I got it from over here in part G. And then VFX equals VOX. I found that way over here. 14.4. And find impact speed. I do Pythagorean theorem. That's VF, where it hits the ground. So that'd be 14.4 squared plus 12.2 squared. Take the square root of that. 2.4 squared plus 12.2 squared equals, and then square root that answer, 18.9 meters per second is what it would hit at. Okay? That's the end. Okay, so I really word this problem out, sorry. But if you get what I was doing, I mean, of course I won't do one like this on the test, but but you should be able to do each individual step just as a practice of a mega problem with different parts.